Welcome to EduPorm EdTech. You're watching expert chemistry lectures with Abhinav Gaur. In this lecture, we will discuss the collision theory. So, according to collision theory, there are following assumptions. The assumption number one is that it assumed that reacting atoms, reacting molecules, and the reacting ions, they are spheres. This was the first assumption. So it assumed that reacting species are ball-like spheres. The second assumption was that these spheres collide with each other and their collision results in formation of product, provided that the collision must be effective. So let's study the points in detail. So first point is, according to collision theory, the molecules collide with great kinetic energy in order to bring about chemical reaction. It simply means that collision results in chemical reaction. The molecule of reacting species collide through space in a rectilinear motion. So the molecules show rectilinear motion and they collide in space. Rate of chemical reaction is proportional to the number of collisions between the molecules of reacting species. That means more the number of collisions, more will be the rate. Provided that the molecules must be properly oriented. Okay, that means there must not be any hindrance. Now, the rate of successful collision is directly proportional to the fraction of successful collisions multiplied by overall collision frequency. The number of collision per second per unit volume of molecule in a chemical reaction is called as the collision frequency. So what is collision frequency? Here we can see that collision frequency is the number of collision per second taking place per unit volume of molecules. Let's say the reaction is A plus B gives C plus D, then the rate is written as Z, that means the collision frequency AB, because the colliding molecules are the molecules of A and B, e to the power minus EA upon RT, where this expression e to the power minus EA upon RT, it represents the number of molecules which are colliding with sufficient energy. Now, in many reactions, the rate can also be written as P ZAB e to the power minus EA upon RT, where Z is called as the steric factor. Steric factor means if there is any hindrance, that hindrance will be explained by this steric factor. Now, let me tell you that these collisions are of two types. First, we have effective collisions. And second, we have the non-effective collisions. Effective collisions are those in which orientation of molecules is perfect. Okay, so the first point is that the orientation of molecules is perfect. Second, the colliding molecules have sufficient energy. That means the collision is taking place with sufficient available energy. And the minimum amount of energy which is required for effective collision is called as threshold energy. The energy is called as threshold energy. Second, we have the non-effective or the ineffective collision. In these collision, the orientation of molecule is not perfect, it is not proper. Second, the colliding molecule do not have sufficient energy for the collision. And third, the energy present with the molecule is less than that of threshold energy. Here it is equal or greater than threshold energy, and here in this case it is less than the threshold energy. Effective collision results in formation of product, whereas in case of ineffective collision, product formation do not take place. Thank you.